Earlier last class we have seen this potential difference and voltmeter, right? So here I'm having a battery. So what is the purpose of battery? Battery helps in the flow of charges, right? From battery only, the stored chemical energy in the battery is gives energy to the electrons to move from one part to another, right? So here if you see, it is written as 1.5 V, right? Okay, 1.5 V, that means 1.5 volt. Here also in this battery is written as 1.5 volt. Okay, here usually they'll say this is 1.5 voltage battery. Okay, what does that mean? Voltage is nothing but here they are trying to say the potential difference. Okay, that means this battery is able to give 1.5 joules of energy to move 1 coulomb of charge. Okay, so if 2 coulomb of charge has to be move, means it will be giving 3 volt energy, 3 joules. Okay, so this is nothing but your potential difference, right? If it is giving in the positive terminal it is giving 1.5 volts, means the difference between these positive and the negative terminal is 1.5, right? So this charge will carry this energy. That means this charge is electron is moving, means some work has been done. So for that work to be done, energy is required. How much energy it is giving? 1.5 joules, right? So it carries this 1.5 joules and it will enter the resistor. Once it enters the resistor, the stored energy, the potential energy, will be lost in the form of a heat. Then in the other side of the wire, it has a very low potential energy, and again this electron will enter the negative side of the battery, right? Negative side of the battery, and again it gains energy. How much energy? 1.5. So what is the difference between the positive and the negative terminal? It is 1.5. The potential difference between this positive here and the negative is 1.5 volt, right? So this will give if any in the battery, this is 1.5 volt battery. If you see any battery, they will mention what is the voltage, that is potential difference created by this battery. Okay, so we'll move to this next part is Ohm's law. Okay, Ohm's law. This Ohm's law was given by a German physicist, George Simon Ohm, in 1827. So to honor him, the law is given the name as Ohm's law. Okay, what he did is he found the relationship between the current and the potential difference. You know what is current? Current is the flow of charges. What is the potential difference? That is amount of work done in bringing one positive charge from one point to another, right? That is potential difference. So what is the relationship exists between these two things? Okay, this current and the potential difference, V, right? So he did his work and he stated that according to this law, the potential difference V across the ends of the given metallic wire in an electric circuit is directly proportional to the current flowing through it. Okay, is directly proportional to the current flowing through it, provided its temperature remains the same. Provided the temperature remains the same in the wire. Okay, so in a metallic wire carrying the electricity, the potential difference is directly proportional to the current. That means you can say that V, the potential difference, is directly proportional to the current. Okay, to remove this proportionality, we introduce a constant. Okay, so V is equals to some constant into I. Okay, once you brought this I down, so V by I is equals to constant. Okay, this constant is denoted by the letter R. Okay, so we can write it as V by I equals to R. This means what? V equals to I into R. That means this potential difference, we said this R is a constant, it remains constant, it will not change, this value will not change. So this means if the current changes, then when the current increases, the potential difference will also increases. If the current decreases, the potential difference is also decrease. Okay, since it is directly proportional. This depends upon this. Okay, V depends upon this I. Okay, clear. So what does this R means? Okay, it is a constant, right? It is a constant value. R is a constant for a given metallic wire. If it is a copper wire, then the R will be same for the copper wire. If you are using that wire, then the R will be same. If you are using any other wire, the value will change. Okay. For copper, it is constant. Okay. At a given temperature, because based on the temperature, the electrons move will differ. Okay. So at a given temperature, and it is called a resistance. R is a constant for a given metallic wire at a given temperature, and it is called this. What is R is called resistance. What does that resistance mean? Resistance is nothing but it is a property of the conductor to resist the flow of charges through it. A wire is there, electrons are moving. When there is a disturbance, when the flow is disturbed, that is called resistance. Right? So even in the circuit diagram we will learn how we will mark this resistance. A wire we will mention like this, and the resistance means some disturbance. The flow is disturbed, and again it comes to normal. Right? So this is a resistor. Resistance. Resistance is nothing but the property of the conductor to resist the flow of charges through it. Okay. So see, V equals to I into R. So we are going to learn about this resistance only. So how can we write this R? R equals to, we need only R. So we will bring this I to this side. Okay. So it becomes V by I. R equals to V by I. V equals to I into R. That means R equals to V by I. So we can define this resistance as resistance of a conductor is a ratio of the potential difference across its terminals to the current flowing through it. Okay. What is it? It is a ratio of potential difference to the current flowing through it. That's it. Okay. Resistance of a conductor is the ratio of potential difference across the terminals and the current flowing through this. Okay. So what is the SI unit of this resistance is ohm. Okay. SI unit of the resistance is ohm. It is represented by the Greek letter. This is a symbol of ohm. Okay. This is actually omega. What is the symbol called? It is called omega. Okay. So what does this 1 ohm means? Okay. 1 ohm means if a potential difference across the two ends of the conductor is 1 volt. Okay. If the potential difference is 1 volt and the current flowing through it is 1 ampere, then the resistance R of the conductor is 1 ohm. So what is the resistance given by that conductor? 1 ohm. Okay. That means 1 ohm equals to potential difference by current, right? Potential difference by current. How much potential difference? 1 volt. How much current? 1 ampere. When the conductor is having 1 volt and 1 ampere current, then we'll say the resistance of the conductor is 1 ohm. Okay. Thank you.